Now let's look at a circuit that's a bit more complicated. In this case, we have a circuit that has two resistors that are in parallel with each other and a resistor that's in series. We know the potential difference supplied to the power source. We know the potential difference for one of the resistors, and we know the current through one of them as well. So using this, we're going to determine the current and potential difference for each of the entities. And we're going to have to look at them together and look at a variety of different features. So like we did before, our first thing to do always is to write down our givens and label each of the entities in our circuit. This will help us to keep our values straight. Okay. Now, we know that resistor 3 right here is in series with my power source. So therefore, all of the electrons that go through here must go through there because there's only one path. They would come out of the power source, they would come down here, and some would go down this branch, some would go down this branch, they'd rejoin back up, and then all of them would go through this resistor. So therefore, if I know the current through this resistor, I know the current that came out of my battery. Okay, now that we know that value, we know the overall current. It allows me to figure out a couple of other different things, like for example, now I can get my total resistance. Okay, now another thing we know though is that these two resistors are in parallel to each other. And we know that objects that are in parallel with each other have the same potential difference. So if this has a potential difference of 12 volts, this must have a potential difference of 12 volts. So therefore I know the potential difference for this resistor. Okay, and because these are in parallel, I can determine the current through this one as well, because I know now that 2 amps comes to this junction, 1.2 amps goes down this way, the remaining would go this way. And so therefore I can use I naught is equal to I1 plus I2, and I can get the current that goes through this resistor. So now that I know the current and potential difference for each of my entities, I can start to solve. However, I still need to determine this potential difference. One of the things I note though is I have a closed loop that goes like this, where it could go through resistor 1 and then through resistor 3. And if 36 volts is given at the power source and 12 volts is used here, the rest has to be used at this resistor. Okay, so first what we'll do is we'll determine the current through resistor 1. We can determine the current through resistor 2. In both cases we're going to use Ohm's law. And we'll determine our total resistance. All three of these were an application of Ohm's law. Now what we're going to do is we're going to determine our potential difference for this resistor. And this should be a volts, not an amps. I apologize. And so what we'll do is we know that we have a closed loop where it goes through this resistor and then its power source, or I have a closed loop where it goes through this resistor, through that one and that. And if 36 volts is applied here, 12 volts is used on this resistor, the remaining has to be used there. Or 36 volts applied, 12 volts used here, the rest is used there. So as a result, I could have two potential equations where V naught, my applied potential difference, is equal to the potential difference of this resistor plus the potential difference of that. Or my applied potential difference is equal to the potential difference of this resistor plus the potential difference of that resistor. Okay. And so as a result, we now know that this is 24 volts. Again, that should be a V, I apologize. And then I can use Ohm's law to get my resistance.